Welcome to tutorial 3. In this tutorial, we are going to learn about transforming variables. As a researcher, many times you need to modify the variables you wish to analyze. You usually do this for 3 reasons. The first is to collapse a variable, combining its values or codes into a smaller number of useful categories. The second is that you might want to combine the codes of different variables to create a new and more precise measure. And thirdly, if you wish to transform a nominal or an ordinal variable into a set of new indicator variables. The variables that we will modify or create in this tutorial will become permanent variables in the datasets, so be sure that you save the datasets after you are done. To start, we are going to close the dataset we are working on now and open a new dataset, NEST 2008. Please note that for this dataset, a weight variable has been created to adjust for distorting effect of oversampling, and we will be using it in our analysis. For more on that, refer to page 44 of the Stata companion book. Using the weight gives somewhat different results. Tab marital alone, and you will get an unweighted frequency distribution, which is not accurate. Adding the weight can be done by typing tab marital, followed by the analytic weight command AW equals W between squared brackets. And here we get the adjusted frequencies. Notice the difference between the two results. Now we want to create a new variable that is called married. How do we do that? This is the first recoding protocol that we will learn. We want to code any married person as 1 and any unmarried person, regardless of the unmarried status, as 0. We will also keep the missing values. To see what are the codes of the variables, we can type tab marital null, meaning no label. Here, we will see that the marital has a code of 1 and the rest are coded 2 to 6. The syntax will look like this. Recode marital, our old variable. We open parentheses and code 1 stays 1, so 1 equals 1, and between quotations we put the new value label. Yes. Then we open new parentheses, 2 to 6 equals 0. Make sure that this is a slash. And between quotations we type no. We include the missing values, so missing equals missing. And then gen for generate married. Always remember to put the parentheses. Always remember to use the generate command with Recode. Otherwise, Stata will replace the existing variable, destroying its code. Remember also for this command, and also for the generate command, that we do not use weights. You can use the weights on the results later. We will come back to the generate command and we will produce the same variable again in a different way in chapter 4 and using the if qualifier that we will also learn in tutorial 4. And finally, we want to label the new variable. So we will ask Stata to label var married is r married. And we can check with tab married and we get our new results. Okay, so let us save what we have done so far and move on to how we can transform interval variables. It is good to play around with the Recode command to get yourself familiar with it. Once you get more used to it, you will find yourself using it to collapse any variable at any level of measurement. However, Recode isn't the best way to transform interval data. We will look at 2 commands now, the generate command, or gen for short, and the xstyle command. With the xstyle command, you can quickly collapse an interval level variable into a few manageable categories containing roughly equal numbers of cases. So for example, you can have quartiles, quintiles, or percentiles. Let us use the example of income, and let's say we want to collapse the income into 3 ordinal categories. We type xstyle income underscore R3, and that is the name of the new variable, and that is equal to the old variable, income underscore R. And then we insert the weights, AW equals W, between squared brackets, comma, and we type n quantiles and 3 between parentheses. You type tab and the new variable, income underscore R3, with the weights, and we get our new variable. Now we move to the generate command, or gen for short. When using gen, you always type in the new variable name, and then you specify after the equal sign your specification. We're going to use a combination of the generate and recode command. Type in gen YOB3, which stands for year of birth, 3 equals recode, and open parentheses, YOB, comma, 1949, comma, 1965, comma, and 1990. What we're telling Stata here is to create a new variable called year of birth, YOB3, and it is the recode of the original YOB variable. And then we're saying that we want to group the variables according to the upper boundaries. And in this case, we are saying that the first upper boundary includes everyone born in or before 1949. The middle group is bracketed between 1949 and 1965. So 1965 is the max, and then the 1990 is the third upper boundary. And then we check if our variable has been created, so we type in YOB3, we include the weights, and there you have it. Suppose that you want to label the new variable which you have created. We use the label define and label values commands. Label var YOB between parentheses 3 generations, so label the value itself, and then label define is used to define the values within the variable. So type label define YOB underscore label, and this is the name we give to the label. And then we label the generations accordingly. And there we have it. The gen command can also be used to create a variety of different variables. Suppose we want to create an additive index. Let's use the example on page 51. And in the NES study, respondents were asked whether certain international policies should be important U.S. foreign policies. These include spreading democracy, promoting and defending human rights in other countries, combating world hunger, and strengthening the United Nations. So now we want to create a variable that looks at how importantly respondents view these policies. We will ask Stata to generate a new variable which will be named intism, short for internationalism. So intism equals goal demo plus goal human rights plus goal hunger plus goal UN, and we press enter. Stata runs the command and deposits our new variable. Let's tab intism and remember to put the weights. You see the high variation in respondents' opinion about the importance of international policies. What this is telling us is that 25% of the sample falls into each of the first three values, and the remaining 25% is unequally divided between the highest two, with only 6.5% of the population thinking that all four policies are very important. What we then do is label the variables. And finally, we check our work by running the tab intisum with the weights. And we can see that we did it correctly. We will now move on to creating indicator variables, or what are also called dummy variables. Let us look at the variable death pen, that stands for death penalty. This variable is a four-category ordinal variable that looks at views over the death penalty from 1 favors strongly to 4 oppose strongly. Suppose you want to create a new variable that looks at each value separately. So for example, give 1 to those who answered favor strongly and 0 to everyone else. The tab command can do this for us. Let us bring back the tab deathpen command from the review window, and we edit by adding a comma and between parentheses death dumb. What this is telling Stata is to create for each value of the variable a new dummy variable. You can scroll to the bottom of the variables window, and you can see that there are 4 new variables that have been created. Remember, we said we just wanted one dummy for the first value. So what we can do is drop the other 3. And we see that they are dropped. Before we end this tutorial, we want to arrange our dataset neatly. So we will type aorder. What this aorder command does is put everything for us in alphabetical order, so it will be easy to refer back to it. And finally, save your work. You should always remember to save your work. And let us move on to tutorial 4.